Let's start by taking a look back at our diagram of how reinforcement learning works. Remember this from before? It shows how the agent performs actions in the environment to receive rewards and learns over time which actions should be taken to maximize rewards. However, something you might have been wondering is how does the agent actually decide what actions to take? More specifically, how does the agent evaluate the current state in the environment and choose an action to, hopefully, maximize reward? To answer this question, we first need to learn about policies. At their simplest, a policy defines the action that the agent should take for a given state. This could conceptually be represented as a table. Given a particular state, perform a particular action. In the example we see here, the state from the camera is a straight track. So the action in the policy is to accelerate. This is called a deterministic policy, where there is a direct one-to-one relationship between state and action. This is often used when the agent has a full understanding of the environment. Given a state, you always perform the same action. Let's take the classic game of rock, paper, scissors. An example of a deterministic policy is always playing rock. Depending on how much notice the other players are taking of what you're doing, this might work for a while, but eventually they're going to realize that you're always playing rock and then adapt their strategy to win, most likely by always playing paper. So in this type of situation, it's not optimal to use a deterministic policy. So what can we do? Well, we can alternatively use a stochastic policy. With a stochastic policy, you have a range of possible actions for a state, each with a probability of being selected. When the policy is queried to return an action for a state, it selects one of these actions based on the probability distribution. In this example, 60% of the time it'll return the action accelerate medium, 10% of the time it'll return accelerate slow, and so forth. This also encourages the algorithm to explore different actions. During training, the probabilities are being constantly adjusted based upon the reward issued for a chosen action. This means the algorithm can converge on the best action, or actions, to choose for a given state, as those will be assigned higher probabilities, and thus will be selected more often. This would obviously be a much better policy option for our rock, paper, scissors game, as our opponents will no longer know exactly which action we will choose. You might now be asking, with a stochastic policy, how do you determine the value of being in a particular state and update the probability for the action which got us into that state? This question can also be applied to a deterministic policy. How do we choose the action to be assigned and taken for a given state? Well, we need somehow to determine how much benefit we have derived from that choice of action, so we can then update our stochastic policy and either increase or decrease the probability of that action being selected again in the future, or in the case of a deterministic policy, select the action with the highest likelihood of future benefit. Let's go back to DeepRacer. Say the policy instructs us to accelerate hard. How do we know whether this is a good or a bad thing? You might have said based on the reward, and you are correct. However, the reward only gives us feedback on the value of the single action we just chose. What really matters is winning or losing the race. So more generally, to truly determine the value of that action and the resulting state, we should not only look at the current reward, but all future rewards we could possibly get from being in that state. So this still doesn't answer the question about how we determine the future rewards from a particular state, but stay tuned and all will be revealed in the next video.